three-phase fault is applied at the point P as shown in figure. So this is the point P. So three-phase fault is applied here. That is second transmission line. So at point number P, the fault is applied. So in this situation, find the critical clearing angle for clearing the fault with the simultaneous opening of the breakers 1 and 2. So this is my breaker 1 and this is my breaker 2. So when you opening and closing of the circuit breaker simultaneously, the fault P is occurred. So in this time, we are going to find out what is the critical clearing angle. One more thing, the reactance values of various components are indicated in the diagram. So generator value is given in the problem, J.25. Transmission line, we have two lines, J.5 line, J.4 line. And after that, we have your bus reactance, that is J.05. So it is connected with your infinite bus. So the infinite bus bar voltage is 1 at an angle 0. So generated transient voltage is E dash, modulus of E dash is 1.2 per unit. And one more key is given. The generator is delivering 1 per unit power at the instant proceeding the fault. So at the time of fault, the generator delivering 1 per unit. Okay. So I already told we have three cases. So we move on to the first case, pre-fault condition or normal operating condition. That is, the fault is not present in the system. So in the P in illa. So when the fault line is not present in the system, it is normal operation. So the normal operation is also known as pre-fault operation. So in the normal operation, I just converting the one-line diagram into a reactance diagram. So this is my generator equivalent. So I have two parallel transmission line, J.5 and J.4. I'm drawing in parallel. So in parallel combination, series with your infinite bus reactance J.05, and you have infinite bus bar voltage 1 at an angle 0. So this is the normal reactance diagram during the pre-fault condition. So in this case, we can able to find our reactance. So the equivalent reactance, I am name it as X1. So 1 means pre-fault, 2 means fault, 3 means post-fault. So in that names, I am mentioning the reactances. So in suffix 1 means pre-fault, 2 means during the fault, and the 3 means post-fault. Post-fault means the system fault is cleared and it is ready to work in normal condition. That is your post-fault. Clear. The fault line is cleared or otherwise. I'll show it while once explaining the post-fault operation. So this is the case pre-fault. So I have J.25 and a parallel combination. So the parallel combination reduction is 0.5 into 0.4 divided by 0.5 plus 0.4. So in series with J.5 plus, so plus 0.05. So once you reduce the values, the answer would be 0.522 per unit. So the overall reactance for the entire single line diagram during pre-fault condition is ready now, 0.522. So next one is I have to evaluate my electrical power PE1. So the general equation for electrical power is modulus of E dash, modulus of V divided by X1. So X1 is nothing but your reactance, which we find earlier. E dash is transient voltage of the generator. V is bus bar voltage into sine del. So we doesn't know the value for del. So I have to keep my del as it is. So E dash is 1.2, V is 1, X1 is 0.522 sine del. So electrical power PE1 is 2.3 sine del. So in the equation வந்து எனக்கு வந்து கிடைச்சிருக்கு. ஸோ ஃபர்ஸ்ட் வந்து என்ன பண்ணுறேன் அப்படின்னா எனக்கு கொடுத்துருக்கிற ஒன்லைன் டயக்ராமை just converting into reactance diagram. So reactance diagram மாத்திட்ட பிறகு அது equivalent. So equivalent reactance கண்டுபிடிச்சிட்டேன். So once I determined the equivalent reactance value, I am substituting in the electrical power expression. So இது நம்ம equal area criterion, swing equation இல்ல basic power equation வந்து எடுத்தது. So E dash Vx1 sin del. So we know all the values except del. So 1.2 into 1 divided by 0.522 sin del is nothing but 2.3 sin del. Clear. So keep the equation 2.3 sin del for time being. So next step. So pre-fault operation. So in the problem they clearly mentioned, so before the occurring of the fault, the electrical power is 1 per unit. So you may notice in the question. Yes. Generator is delivering 1 per unit power at the instant preceding the fault. So fault ஆகிறதுக்கு முன்னாடி இருந்த power வந்து 1 per unit. So your PE1 should be your 1 per unit. So I am substituting here. So 1 per unit equal to 2.3 sin del naught. So why I am changing del to del naught means it is the initial operation. So only I am keeping my angle as del naught. So del is modified as del naught because of the initial load angle or initial fault proceeding angle I need to know. So I am changing del to del naught. So 1.0 which is equal to 2.3 sin del naught. Obviously your sin del naught equal to 1 divided by 2.3. So 0.4348. So I need the angle in terms of degrees means I have to take sin inverse. So sin inverse of 0.4348, 25.8 degrees. In order to converting the values into radians means pi by 180. So it is 0.45 radians. So this is my initial pre-fault operating power angle. So it is the integral limit. So only I am proceeding these steps. So during the pre-fault operation, so the pre-fault operating power angle is determined easily. So அதுக்காக தான் நம்ம வந்து pre-fault operation வந்து போறோம். எந்த ஆங்கிள்ல இருந்து எனக்கு வந்து fault ஆக போகுது அப்படின்றத கண்டுபிடிக்கிறது தான் இந்த pre-fault operation. I hope you people understood this step or case. புரியுதாமா? Del naught வந்து 25.045 radians. So the initial angle, operating angle. So இது வந்து pre-fault. So normal operation, you doesn't have any problem, any issues. So next one is we move on to the real problem. So during the fault. So the fault occurs at the end of the line 1 or near bus 2. So end of the line 2 அப்படிங்கிறது இதுதான். ஸோ உனக்கு பிரேக்கருக்கு அப்புறம் போட்டிருப்பாங்க. மெயின் டயக்ராம்ல பார்த்தீங்கன்னா, so before the breaker you have the point P. So this is the fault point. So in this point your system is get faulted or the entire line gets affected. The breaker 1 and 2 gets affected. So the line is split into two portions. That is generator transmission line. It is splitted. So the J point for the middle line should be splitted. So I'm just separating the circuit or network. So J.05 infinite bus bar is separated. So from the circuit during the fault, it is cleared that no power is transferred. So during the fault operation, you couldn't operate your electrical power. So the generator should be shut down. So then only the fault is cleared. Correct? So நம்ம ஜெனரேட்டர் ஆன்லைன்ல அப்படியே நம்ம வந்து ஃபால்ட்டை வந்து கிளியர் பண்ண முடியாது. ஸோ சம்டைம்ஸ் ஆர் சம் ஹவர்ஸ் இட் வில் டேக் டு ரீஸ்டோர். அதனால வந்து ஜென்ரேட்டரை ஷட் டவுன் பண்ணிட்டு அந்த ஃபால்ட்டை வந்து சரி செய்வாங்க. So I just assuming my electrical power is not producing here. So it is 0. There is no power transfer during the fault operation. So this is the second case. So during the fault operation, your electrical power is not transferred. So the faulted line should be identified and splitted. So that is the second case. So third case is post-fault operation. So what is post-fault operation means? The fault is cleared by opening the faulted line. So you people aware of what is the faulted line. So faulted line is nothing but your second transmission line, J.4. So you just remove the faulted line. If I am removing the faulted lines, I am having remaining 3 branches. That is J.25, J.5, J.05. So 3 elements are connected in series. So the reactance X3 is 0.25, 0.5, 0.05. Adding the 3 values, the value should be 0.8. Correct? So next one is I need to find out the maximum angle. So in the pre-fault operation, we are determined the initial load angle. In the post-fault operation, we can easily find out our maximum angle. So maximum, minimum. So the integral limit is evaluated during the 3 cases. So we know that power angle equation is P3 is E dash V X3. So it is a post-fault, so 3 sin del. So the del value not known to us. So keep the value as it is. So 1.2 into 1 divided by 0.8 sin del. So if you are simplifying 1.5 sin del, so I can say the maximum value should be 1.5 times. So the maximum permissible angle del max. Hello. 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 So okay. So the maximum permissible angle del max for the area A1 equal to A2. So by applying equal area criterion, so area 1 equal to area 2. So the del max equal to, so for the half of the phase is 180. So the full cycle is 360. Half I am taking. So 180 minus sine inverse of Pm by P max 3. So here Pm is mechanical power. When your power system, your electrical and mechanical is coupled, so Pm. So generally we can assume the value as 1. So del max is nothing but pi minus sine inverse of 1 divided by the maximum value in the post fault is 3. It is 1.5. So pi minus sine inverse of 1 divided by 1.5. You can get the maximum load angle is 2.41 radians. So the minimum angle is 0.45 and maximum load angle is 2.4. So now we have to find out the critical clearing angle. That is our intention. So in the problem, we need to find out what is the critical clearing angle. So del CC or del CR. In some books it is del CC. Some books it is del CR, critical clearing angle. So in this book they are mentioning del CR. So this is the corresponding power angle curve for determining your critical clearing angle. So in your y-axis you have electrical power and the x-axis you have load angle. So you have 3 powers. So what are the power 3 cases. What are the cases we have? Pre-fault, post-fault and fault. So faulted, you doesn't have any electrical power. So the first large curve is your electrical power one. That is during the pre-fault, you have the value of 2.5 2.5 or 2.3 signal. So the magnitude is high, 2.3. So after the PE3 வந்து பாத்தீங்கன்னா it is 1.5. Second curve. Fault we have no electrical power, so you have no curves. Is it okay? So the PE1 is 2.4, PE3 is 1.5. So when you have the applied mechanical power, so now mechanical power on the 1 per unit on the apply பண்ணும்போது I have a horizontal line here. I just intersect with my horizontal line in the curve. So first cut ஆகுது இல்லையா? So the mechanical power means your first point, touching point. So that is your del naught initial angle, initial power angle. Del naught V determined as 0.45. Correct? So this is the fault rise or maximum point. So in this place, you have the maximum rising of your fault. So it is del CR. Okay. So next one is after the curve ending, that is the fault is cleared and it is settled to your normal operation, you have the another point, intersecting point. So I can say it is del max. So my integral limit should be del naught to del max. So it is your pi. So I am considering off cycle. So we have regions. Regions wise, we have the limits. That is the A naught is del CR to del naught, one limit. And the A2 is del CR to del max. We have two regions. Correct? இது ஒரு ஏரியா A1 அப்படிங்கிறது ஒரு region. Area A2 அப்படிங்கிறது ஒரு region. So A1 equal to PM del CR minus del naught. இது வந்து அப்ளை பண்ண லிமிட் அப்ளை பண்ணது. So integral PM del. So del CR to del naught on the limit. So simplify பண்ணிட்டாங்க, இவங்களே பண்ணிட்டாங்க. So PM is 1, del CR value unknown, and del naught is 0.45. So multiplying del CR minus 0.45, that is my A1 value. So what is A2? A2 is nothing but del CR minus del max. So here PE3 minus PM. So the PE3 is cutting here as well as PM. So PE3 minus PM, d del. So PE3 value is nothing but 1.5 sin del minus 1 into d del. Limit is del CR to 2.41. Del max value is 2.41. So integrate. So integral of 1.5 sin del is minus 1.5 cos del. Integration of d del is del. So once you applying the upper limit minus lower limit. So minus 1.5 cos 2.45 minus 2.41 minus of minus 1.5 cos del CR minus del CR. So we have to keep our del CR value as it is. So simplify further and further. So you may have the equation like this. So minus 1.293 plus 1.5 cos del CR plus del CR. So area 2 should be the equation minus 1.293 plus 1.5 cos del CR plus del CR. So I am applying equal area criterion. What is the equal area criterion? The condition is area 1 equal to area 2. So this is my area 1 value, del CR minus 0.45. And this is my area 2 value, minus 1.293 plus 1.5 cos del CR plus del CR. So now I bring my del CR. Here it is plus del CR. If I am bringing to the right hand side, it is minus del CR. So minus del CR plus del CR get cancelled. One issue is over. So if I am bringing 1.5 cos del CR to the left hand side, or otherwise I have to fixing my 1.5 cos del CR here and 1 point minus 1.293 to the left hand side. Already we have minus 0.45. Here it is minus. If we are moving to the left hand side, it's plus 1.2934. So 1.5 value is moving to the denominator. Correct. So del CR equal to minus 0.45 plus 1.293 divided by 0.45. So if you are simplifying, the value should be 0.562. So I need the angle or radians. So del CR equal to cos inverse of 0.562. It is 0.974 radians. If we need an angles means 0.974 into 180 by pi. So it is converted into degrees, 55.8 degrees. So this is my critical clearing angle. So in this manner, we have to find out your critical clearing angle. So this is your analytical method to solve your critical clearing angle. So we have direct relation also. உங்களுக்கு வந்து இதெல்லாம் நீங்க அந்த ஏரியா 1 ஏரியா 2 எனக்கு வந்து சால்வ் பண்ண முடியல கஷ்டமா இருக்குன்னு சொல்றவங்களுக்கு வந்து பாத்தீங்கன்னா you have another option, but you have to remember the equation. So this is the equation. So directly we can substitute the values in this equation. So இது வந்து derivation. இந்த derivation நம்மளுக்கு வேண்டாம் அப்படின்றதுனால நான் கடைசி மட்டும் காமிக்கிறேன். So cos del CR equal to PM del max minus del naught minus P max 2 cos del naught plus P max 3 cos del max divided by P max 3 minus P max 2. So if you are substituting the values here in this equation, you can easily get your del CR value. So finally, நீங்க cos inverse எடுத்தீங்கன்னா del CR கிடைச்சிடும். So you can use either this equation or analytical method. So ரெண்டுமே கரெக்டா தான் ஆன்சர் வரும். ஸோ அடுத்த ப்ராப்ளம்லாம் வந்து பார்த்தீங்கன்னா உங்களுக்கு அனாலிட்டிக்கல் மெத்தட்ஸ் சாரி இந்த ஈக்குவேஷன் யூஸ் பண்ணி 2-3 ப்ராப்ளம் இருக்கு. ஒரு நிமிஷம் அட்டெண்டன்ஸ் க்ளோஸ் பண்ணிடுறேன். Any doubts or clarifications needed? இந்த ப்ராப்ளம்ல டவுட் இருந்தா கேட்கலாம். உங்களுடைய இன்டர்னல் 2 வந்து 23rd இருந்து ஸ்டார்ட் ஆகுது. So from 23 onwards you have internal 2. So the syllabus for PSA is unit number 3 and 4. சரியா? Unit 3 and 4 வந்து உங்களுக்கு PSAக்கு syllabus. உங்களுக்கு அந்த ரிவிஷன் கிளாஸ் வச்சாங்கன்னா 3 and 4 வந்து நான் ரிவைஸ் பண்றேன். என்ன டேட் 18. Yeah.